Good afternoon, everyone. Today, I'm going to talk about the serverless applications running on containers. So, my name is Justin from Maxia. As a senior consultant, I am a double awarded Microsoft MVP in both Azure and .NET. And these are my social media profile. So if you are interested in, just follow me on Twitter or blog or LinkedIn. Now, I'd like to really thanks for our sponsors. Without them, DDD Sydney wouldn't be happening tonight. Now, before starting, I'd like to ask a very simple question. So the topic of this session is about both containers and serverless applications. So is there anyone using the containers at work or personally? How many? Wow, many. Yeah. And what about the serverless applications, including Lambda, Google Functions, or Azure Functions? Yeah, still many. Yeah, which is great because I asked the same question last year at DDD Sydney. Then the number of the people using the serverless application is quite increasing, which is good. But still, almost half of the people in this room don't use the either container or serverless application. So yeah, I'm staying this session as an introductory session. So yeah, but I'm expecting that at the end of this session, you guys to have at least one idea how we build the serverless application in container. So, so from this point of view, so I'm going to start build the Azure function code with using the C# on the Linux environment. Then I'm going to Dockerize that serverless Azure function application into a container. Then with this container, I'm going to deploy that into Azure through Azure portal, then Azure CLI, then the ARM template. So if you're interested in. So before jumping into the writing the applications, think about these 4 different types of these cloud services. So as you can see, left-hand side is the IaaS, which is a bunch of virtual machines. And the right-hand side is functions, right? Function as a code. So in between, there is a container as a service and platform as a service. So what do you think from when you, as soon as you see this screen, what can you imagine what's going to be happening? So from the management focus point of view, so what we are focusing is in IR side, we are focusing more on infrastructure side. On the other hand, the function as a service side, we are more focusing on the code side, right? So in terms of the abstraction level, so we have to take care of everything in IR side. We have to deploy virtual machines, we have to deploy the network interface, we have to set up all the firewall rules, etc., etc. Then in the container as a service side, so the abstraction level is very low in the virtual machine. Then the basic operating system is abstracted in the container as a service. So we only care about the containers, but we still need to consider about the scaling stuff. Then in path side, we only care about applications rather than all sort of the environment, right? So we don't have to worry about servers, we don't have to worry about the scalings, something like that. But we still need to worry about the application, right? Application like the load balancing or something like that. At the end of the function as a service side, we only focus on code, right? So we only focus on each functions, right? We don't have to worry about application as a whole, right? So everything is abstracted. Even we don't have to worry about the scaling. So when the traffic goes in increasingly, then it automatically scales out, something like this. So in terms of abstraction level, the function is the fully abstracted, and in terms of the abstraction level on the virtual machine side is we need to the abstraction is rarely did, so we need to care about everything. So from this slide, so we are talking about the container and serverless. So definitely serverless goes into the function, but the container goes into the here, right? But do we really, so what is the serverless application actually sits in here? Do we need to consider CAS or do we need to consider FAS? So I think we still focus on the code side here, but we take benefits of using container technology. So why do we use containerizing, or why do we use Dockerizing here? So so in generally speaking, the reason why we are using container technologies is about the build infrastructure very easily, regardless of the environment, right? So, or one of the benefits using the containers is kind of lift and shift the scenario, which is migration from one place to another very easily. So, which is something, this kind of scenario is very general. So I have a customer, they want to, they have currently hosted all their applications on-prem side, but they want to migrate, like cloud migration project or whatever. So they want to migrate all their on-prem applications onto cloud without minimal effort. If they run containers in their on-prem environment, and we don't have to too much worry about the migration cost, because we already use some container and just lift the container, pull out the container from the on-prem side and just deploy into the Azure. That also happens to the cloud, the vendor agnostic. What means as long as container is supported by different the cloud service provider, then we can actually migrate from one cloud vendor to another. For example, from Azure to Amazon, or vice versa, Amazon to Amazon to Azure. Right? So so these services are currently, as far as I know, they support containers. For example, so Azure Cloud, AWS Cloud, Google, and OpenStack and Azure Stack. So so both the bottom two is about the on-prem. We consider on-prem, but the top three is the public cloud side. So we can actually freely migrate one place to another. But as I said, we are building serverless applications, which means we still focus on code side, right? Then we take benefits from the container technology by using different packaging approach, right? Instead of using the web deployment package, we just use containers for the application packaging and deployment. So those who are not familiar with serverless applications, so we understand why we need containers, right? Now, why do we need to write a serverless application, especially for Azure Functions? So I will point out a few characteristics of using the serverless application here. So the nature of serverless application is that, as I said, we don't have to worry about building or setting up the old server environment. We just focus on the business operation and the business logic. Also, the serverless application, the nature of a serverless application is the event-driven, event-based. So actually the number of events coming into the application going up, it automatically scales out. On the other hand, if the number of events the coming in to the serverless application goes down, it automatically scales in. So we don't have to worry about scaling in here. So, so Microsoft or the Amazon, they don't have a measure of how they charge us because we don't have the virtual machines, we don't have the app service instance, whatever. So they only charge us the number of executions and the time of the executions. I mean the length of execution times, right? So we often call as the micro billing here. Now, one of the characteristics of using the serverless applications is serverless applications rely on a bunch of different type of events, including HTTP request, timer, or service bus message, or event grid, or Cosmos DB, whatever. Right? So these are all different events. So as long as the serverless architecture supports a certain type of event, yeah, that should be fine. Now, one of benefits using the Azure function is Azure function actually supports wider range of the different languages than any other the serverless applications. So in theoretically, serverless architecture should support any type of language. But in reality, there are some limitations. So Azure function supports those languages. JavaScript, C#, F#, and Java, they are the most frequently used, and the Python, PHP, PowerShell, and so on. They are also used, but I'm still experimental at this moment. Now, think about the HTTP trigger, right? So when we build the Azure function or serverless applications with HTTP trigger, it's basically the same as Web API, right? Because it takes an HTTP request and it returns a response. Now, because with this, and Azure function is very optimized for the microservice architecture. Actually, it is forced to consider Microsoft architecture because they charge us the length of execution. Right? So if we run the Web API with a long running period of time, then they will charge more, and we have to pay more. Right? So we have to consider to build the Web API as short as possible. So which means we should consider each endpoint take only a single responsibility, which is unit of work. Now, so we have reviewed why we consider containers and why we consider the serverless applications. Now we are moving on to building Azure functions. So I'm going to write an Azure function here on a Linux environment. Because currently the Azure function supports the .NET Core, right? So and the Dockerizing, the container is only supported in the Linux environment. So we should stick on the Linux. So we need to write this code on we need to build this application on the Linux environment. So this is the basic code. As you can see, it's very simple as a function. So it takes the query, the query string of name, right? And it returns the hello world something. Right? It's very simple the Azure function application. Now with this, in the Linux box, for example, if you are using the Windows 10, and you can use the Windows subsystem for Linux, right? Or you can simply use the Linux box here. So after we write the code and we build that application using .NET CLI, then we can test it. So let's have a look at this video. So now we have we have a test HTTP trigger here, and I just paste the code that I showed you, and we build it. So we save that application code. Now we use .NET CLI to build that application within the Linux environment. So once we run this, and it gets all the dependencies from NuGet, and it builds the Azure Function application like this, right? So once we're done, we run the Azure Function CLI to host this function application in our local machine. So once it's done, and usually Azure Function application running Azure Function CLI use the 7071 port number. So we just copy that URL and run this on our local browser to actually test if it is running properly or not. Now, it is running fine. So we have built our the Azure Function application on our Linux environment and build it properly. Now, we are moving on to the Dockerization. So in order to build custom container, Docker container image, we should write Docker file here, right? And in here, we are using the multi-stage build approach. So Docker file actually contains two different sections. One is using the container for the .NET Core SDK, and the second one is as a function runtime, right? So with this the container, we copy the function code and build it inside this container. Then we just give up using this container. Instead, we pull out this as a function runtime and copy these DLL files into this runtime container and build it. So this is how Dockerfile defines that we build custom container image. So once the Dockerfile is ready, and we run Docker CLI to build this custom container image. Then once with that, and we can test run this container image on our local machine. And yeah. Now, so let's have a look at this video. So we have an empty Docker file here. We open this Docker file and paste the Docker definition file here and save it. Now, we build this Docker image. So it's done. So when we check this Docker image and we find the function app here. So now we run this in our machine. So this time we use 8000 port number. Now this is running. So we confirm we properly build custom container image in our local machine. So once we finish the container, then we need to upload this custom container image to like Docker Hub or private Docker repository or Azure Container Registry. So we need to upload it. Then also we need to check if that custom container image is properly uploaded or not by downloading and running locally in our machine again with different port number. So this time, let's have a look at another video. So we have the function application, container image. Then we give a tag for that container custom image for Docker Hub upload. Right? So we use Docker CLI to push the custom container image to Docker Hub. So at this stage, we are using the public Docker Hub. So, but if you are using Azure Container Registry, we need to log in a different way. But the command is the same. So we built it. Now we are running different port number, which is 8888, which is running fine. So test it on our local machine with different port number. So now we confirm we properly uploaded our custom container image onto Docker Hub. So we are ready for deploy. Now, so this custom container image need to be deployed into Azure. So this time we are using the Azure portal. So in order to deploy this in Azure portal, we need to first of all we need to create the Azure resource group, then a storage account, then app service plan. But at this stage, usually Azure Function is used for the consumption plan is used for Azure Functions. But consumption plan doesn't support container at this stage. Also, Windows App Service Plan doesn't support container either. So only Linux App Service Plan is supported the container scenario. So we need to create App Service Plan for Linux at this moment. Now, when we create Azure Function instance, so yeah, instead of using the Windows or Linux, we choose Docker. Right? So we choose Docker and give the container, like the container repository on the Docker Hub, like this, right? And create it. So once it is spin up, it is the function app is up and running on the with this name, the DDD portal here. But the problem is that when we see here, usually once the function as a function instance is up and running, we can see the endpoint here, right? But we can't see at this moment because the app settings is not properly set up. Right? So actually, this is nothing wrong with us. It's actually bug on the Azure portal. So we need to take another step to make this work. Right? So we need to set up the additional. We need to put additional settings on the Azure portal, like this. So in here, so we need to put storage account, and we need to put the Docker custom image. Right? Even though we already defined the custom Docker the repository, we have to do it again in here. Right? Then once we save it and it spins up, and we get the test the HTTP trigger function endpoint. Right? So once it is done, and we can simply visit this website, so which is the function app as a website, right? And then send a request like this, then we can get the result. So we successfully deployed the containerized function instance to Azure portal, through Azure portal. But usually using the Azure portal is kind of we need to quickly make something happen. But this time, this is kind of buggy, so I'm not happy with that. So instead of using Azure portal, we can use Azure CLI. The reason behind we are using Azure CLI is we are running on the Linux environment now. So yeah. So of course, the current Azure PowerShell is the cross-platform, but Azure CLI is much better, give us a much better experience. So we can stick on the Azure CLI. So first of all, we need to log in Azure CLI, then create an Azure function instance with just one line of command like this. So Azure function app creation, by giving resource group, the function instance name, and storage account name, and the app service plan name, and finally we give the Docker Hub, the custom container image repository like this. So once we run this command, it automatically spins up as a function instance without any hassle. So once it's done, and we can go to the website like this, the function app CLI as a website, then send a request and we can get the result, which is, we confirm that the Azure function instance, container instance is properly deployed onto the Azure through Azure CLI. This time, so if we are concerned about the build and release automation, right? So think about we are a DevOps engineer. Then we need to think about the ARM template stuff, right? So we need to think about the ARM template. So in order to do so, we need to write down the ARM template. So this is the shrink version of the ARM template, right? So we need to define storage account within the ARM template, then app service plan for Linux, then as a function instance, right? So under the function instance, we can define the Docker custom image here, right? So these are all the app settings value. So we can actually put those functions and the values within the ARM template. Once the ARM template is done, and we can simply log on to Azure CLI and deploy this ARM template by running this command. So group deployment with by giving the resource group name, deployment name, and template file and parameter file like this. Right? So once it's done, actually this is running as ARM template. So it automatically deploys the storage account, the app service plan, and the function instance as well. So it's all done in one go. So once it's done, so it automatically deploys into the website here. So run this, hit this website with by sending a request to request like this. Hello ARM. So this is done. So we have built as a function application in a Linux environment, containerized it, and deployed that custom container image into Azure in 3 different ways. Now, as I said, as long as any cloud vendor support container technologies, we can actually migrate one place to another, right? Which is vendor independent. One of the problem issues using the serverless application is very tightly coupled with the vendors. So it's vendor lock-in, right? So we cannot use Amazon Lambda onto Azure, right? We cannot use Azure Functions onto Amazon, right? But if we are using containers, that we can. So why don't we deploy this Azure Function instance onto Azure, the Amazon? So I'm going to show how we can deploy Azure Function instance onto Amazon ECS actually. So in order to do so, we need to set up the Amazon ECS, which stands for Elastic Container Services. I think this is the equivalent to Azure Container Instance Service, right? Then once all the setup is done, and we can simply test, visit the website like this using Amazon AWS.com and send a request like this. Okay. So this is the short video that I actually made it happen. So this is the Amazon ECS, the console screen, and to create a cluster using the custom image, custom definition, I mean. So give a container name of the Azure Functions on ECS. Now we give the Docker Hub repository name. Then everything else is just default value like 51, the memory size and port number. And the other thing we need to think about is if we want to use Amazon ECS, we need to set up the application load balancer here. Right? So this is the only difference between the Azure and Amazon. So it's spinning up now. So it's done. So once it's done, we can go to service, and we have already set up the load balancer. So go there and get the endpoint name. Right? So we get this endpoint and go to open the browser and go there. So the app as a function instance is up and running now, and the endpoint is actually running. So so this is possible because we are using the container technology. Now, almost there. So throughout this session, we have built the Azure Function application in C#, .NET Core in the Linux environment. Then we make it a custom container image with Docker container. Then we deploy that custom container image through onto Azure through Azure Portal, then Azure CLI, then ARM template. And finally, we also deploy that Azure Function custom container image onto Amazon ECS. So this is it. So any questions? So your question is about if we deploy the Azure function instance onto Azure, it automatically recognizes Azure function. But if we deploy this Azure function instance onto Amazon, does it recognize Lambda or function? Is it your question? Yeah. No. I mean, so we are not using Amazon Lambda here. We are using their container services. So we just pull out the container to their container service. That's it. So from this point of view, we can actually deploy this Azure function instance to the Azure Kubernetes service or the Azure container instances, something like this. So as long as container technology is supported, then yeah, it's fine. So because container has all the Azure function runtime, so it's not interrupted by any Amazon Lambda stuff. Yeah, does it answer the question?
Yeah. So this is this.
Yeah, that's a good question. Actually, I don't know. The performance difference probably when you deploy this the Azure function application on the, using the container technology, it takes time to spin up. So when I last time saw that it takes about 5 to 7 minutes, which is longer than I expected. And but if we deploy this into like Amazon ECS or the Azure ACI, then it actually automatically it actually very fast to spin up everything. So I think the reason behind is we are running the Azure function right on top of the PaaS, right? PaaS instance is everything spins up behind the scene. Actually, we don't have to care about that. So based on that, it takes time, and also it takes time to pull out the image and running on top of PaaS environment, something like this. So yeah, that takes time. So this is the only differences in terms of the performance-wise. But other than once it's spinned up, and everything else is the same. The question is about the serverless architecture is automatically scales out. But if we use container, is it automatically scales out? So that's the question, yeah? Yes. So think about this. We are using containers as the different type of packaging. So we are not. So it's actually the runs on top of PaaS. So it's basically the fast application. I mean the function as a service application, right? But only use containers for different packaging. When we think about when we deploy the Azure function application through the Visual Studio or the CI/CD pipeline, then we firstly build the package, web deployment package, right? So instead of building web deployment package, we create custom container image. That's the difference. So all the scaling thing is managed by PaaS and fast side. So we don't have to worry about the scaling.
So who's scaling in the Amazon ECS side? I mean, what is this unit of scale?
In the Amazon ECS?
Yeah.
I have no idea. I'm not an Amazon expert, so I cannot say how to do that. But I believe the Amazon ECS is quite similar to the Amazon Azure ACI. So ACI, from the ACI point of view, we need to take care of the scaling by ourselves. I think the Amazon ECS will be the same.
So we lose one benefit of Azure Functions just by putting that into a container. Is that?
Yeah. So currently it's very kind of the experimental, but we still see the possibility of the lift and shift scenario. But other than lift and shift scenario to different the cloud vendor doesn't guarantee of any sort of scaling kind of things. That thing need to be considered by the different the cloud vendors.
But how does it guarantee in the Azure container service itself?
Azure container service also doesn't guarantee the scaling, right? So we need to set up the scaling, as far as I know. Yeah. I haven't tried. Yeah, because I think I'm pretty sure that that's not possible because that queue trigger or service bus the trigger or something like this, that's actually depends on the Azure services, right? So yeah, we are thinking of the HTTP trigger, right? So that HTTP trigger definitely works fine. So the cost, from the cost-wise, if we are using the Azure Functions in a consumption plan, right? We only pay for the pay by execution, right? But we are using the Linux Azure app service plan, which is different, right? So we need to pay for the app service plan itself, like the S1 tier maybe $150 per month or something like this. Yeah. But we don't have to pay anything more. The question is why do we use container for Azure Functions? Is that the question? Yeah. Yeah. Yeah, it's probably too many. So why should we use container? Why Dockerizing? Yeah, we actually covered that probably
Sorry, that seemed to be why Dockerizing in general, but why Dockerizing functions in particular?
Yeah, so there are actually many needs that the customer wants to run these Azure Functions on their local, the on-prem environment.
Oh, so for on-prem.
Yeah, for example, currently Azure Function is the vendor locked in. I mean, the only runs on the Azure portal side. But if we use containers, right, we can actually move from the Azure public cloud to Azure Stack, which is our on-prem. So that kind of a scenario is happening.
So in what way this is different to serverless framework? Have you heard of serverless?
Serverless framework, yeah.
Like from the previous talk, there was the serverless like abstraction that used Cloud Foundry to abstract going to Azure or AWS or different vendor.
I honestly don't understand the question. So could you rephrase your question again? So are we talking about serverless framework or?
Yes, the Node.js serverless framework, serverless.com.
Yeah, we are. So the topic of this session is about Azure Functions, not the serverless .com, the serverless framework. So this is we are using the C#. But in terms of using Node.js in Azure Function, right? And we can do this within the Node.js, I think. But I'm not a Node.js person, so I can't really answer the clear answer. Container for Azure Functions?
Yes.
If I understand the question correctly, the Azure Functions for the container scenario only support a single container scenario rather than multi-container scenario. But so other than the Azure Functions, just if we think about the normal web application hosted by the Azure App Service Plan, then we support multi-container the scenarios. But Azure Function, we only support a single container. So yeah, so at Nexia, we are actively hiring the Azure expert. So if you are interested in, just reach me, then we can start discussion from here. Thanks for listening.